Good morning, students. Today we will be discussing about infiltration. So before moving into the topic of infiltration, I would like you to know few things. Now you can see here, I have written here, rainfall is equal to interception plus depression storage plus infiltration plus runoff. What does this mean? When rainfall occurs on a particular land, suppose this is a land surface, okay, this is a land surface, and here this is the water body. Fine. Now when rainfall will occur on this land surface, what will happen? This is rainfall, or you can say this is the precipitation. Now this precipitation will be intercepted by the vegetation that is present on the surface. Okay, vegetation like trees, shrubs, grasses, all these are the vegetation which will catch hold of the rainfall water. So that process is known as interception. Okay, what is interception? It is the process by which the rainfall water is caught hold by the trees, plants, shrubs, grasses, or in short, the vegetation. So that process is known as interception. Some of the water may get stored in this depression. You can see this depression over here. You can call it depression or you can call it potholes. So some of the water may get stored in this depression, and that is known as the depression storage. Okay, some of the rainfall water may get stored in the depression storage. Next, some water may get infiltrated into the soil surface. Some of the water may get infiltrated into the soil surface. So that process is known as infiltration. This we are going to see today. So what is infiltration? It is the water which seeps into the soil, or you can say it is the rainfall water which seeps into the soil. That process is known as infiltration. Some of the water will flow into the water bodies. Okay, the water will not remain on the surface of the earth, on the ground surface. What will happen? It will try to flow towards the water bodies like lakes, rivers, oceans. Okay, whatever water bodies are there, it will try to flow into these water bodies. So such process is known as runoff. Okay, such process is known as runoff. Runoff can also be known as surface runoff, or it can also be called as direct runoff. Runoff is also called as surface or direct runoff because this is taking place on the surface of the soil, above the surface of the earth. So it is also known as surface runoff, or it is also called as direct runoff. Okay, so this is how all the water from the rainfall is distributed on the surface of the earth. Based on this distribution, these are the important terms that you have found out. Now today's topic is about infiltration. Okay, today's topic is about infiltration. And what is infiltration? It is the seepage of water, seepage of rainfall water into the soil surface, inside the soil surface. Okay. So now as per your gate, some few terms are very essential. Okay. infiltration capacity, actual rate of infiltration, and rainfall intensity. See, these terms are very important, okay, because these terms can be used in your gate exams as well, okay. So first, what is infiltration capacity? Infiltration capacity, it is nothing but, it is the maximum rate at which water can be absorbed into the soil, okay. Every soil will have different infiltration capacity rate. So, infiltration capacity is the maximum rate at which water can be absorbed in a particular soil. So, that is denoted by small f. That is denoted by small f. Next is the actual rate of infiltration. Actual rate of infiltration means it is the actual infiltration capacity. This too can vary actually, depending on the soil conditions and the climatic conditions. These two can vary, okay. And actual rate of infiltration is given as FA. It is denoted as FA. And rainfall intensity. What is rainfall intensity? It is the amount of rain falling in a particular area in a given time period, okay. So it is given in small I. It is denoted as small I. Now you see, this equation is very important. Okay. When I is greater than or equal to F, that is, when rainfall intensity is greater than or equal to the infiltration capacity, then the actual rate of infiltration will be equal to the infiltration capacity. Okay. This you have to keep in mind. When rainfall intensity is greater than or equal to the infiltration capacity, then actual rate of infiltration will be equal to the infiltration capacity. And when rainfall intensity is less than the infiltration capacity, then actual rate of infiltration will be equal to the rainfall intensity itself. Okay. So these two are very important as far as your exam is concerned. As far as your gate exam is concerned. So please keep this thing in mind. So based on the infiltration capacity, we have the infiltration capacity curve, which is also called as the IC curve. Okay, infiltration capacity curve. Now what happens in this curve? We get a plot of infiltration capacity with time in a given time period. This infiltration capacity is plotted in a given time period. Now you can see here, this infiltration capacity F is denoted in centimeter per hour, and here the time is denoted in hours. Okay, this is small f, that is the infiltration capacity. Small f is in centimeter per hour and time is in hours. Now what happens here, as rainfall starts to occur, in the beginning of the rainfall, the infiltration capacity will be at the maximum. It will be the highest. Okay. When there is long dry periods of rain, when rain has not occurred for a longer time, and when rain starts to occur, then at that moment the infiltration capacity will be the highest. As more and more rainfall occurs, the curve slows down. Okay, the curve reduces considerably and it reaches to a point of constancy. Okay, it reaches to a point of constancy. Now as I said, rainfall at the beginning, the infiltration capacity will be the maximum. Okay, as and when rainfall occurs, the curve will reduce considerably. And it will be constant at one particular time. Suppose it is constant at one particular time, capital T, then at the time capital T, the infiltration capacity will be denoted as Fc. When Fc is denoted, then the value of infiltration will become constant. Okay, the value of infiltration here at this point, the value of infiltration has become constant. From here, the line is going straight. Okay, the line is going straight. So Fc is that value of infiltration where it is having a constant value, where infiltration is having a constant value. And for example, from here to here, from this point to this point, if you want to plot the actual infiltration, then you can plot it at a given time t, you can plot the Ft, that is infiltration capacity at a given time t. Here the time was 0. When time was 0, that is at the beginning of the rainfall, the infiltration capacity is Fo. At time capital T, when the infiltration capacity value is constant, then it is denoted as Fc. And if you want to calculate it between 0 to capital T, that is, if you want to calculate the value of infiltration capacity at any time t, then you can get the value as Ft. And that value, that equation is given by the Horton's equation of infiltration capacity curve. This is the Horton's equation. Ft is equal to Fc plus Fo minus Fc into e to the power minus kT, where Fc is the value of infiltration after reaching a constant value. Okay, as I told you here, this is Fc at any time capital T, where it has reached a constant value. What is Fo? Fo is the infiltration capacity at start. See, at start the infiltration capacity is Fo. What is Ft? Ft is the infiltration capacity at any time t. This is Ft. At any time t, the infiltration capacity is Ft. Here there is a term called small k, and that small k is the decay coefficient. Okay, this small k is the decay coefficient, and this is denoted, actually its unit is in time inverse, or 1 by t. Time is normally given in hours. So here the value of k will be in hour inverse, or 1 by hour. And small t is the time from beginning of rainfall. See, the small t, it is time from the beginning of the rainfall. So this equation is known as the Horton's equation of infiltration capacity curve, and this is the curve that is plotted. This curve is plotted against the infiltration capacity with the given time period. Okay, with the given time period. Now here is a typical question, very easy question. Draw a typical infiltration capacity curve and indicate on it the various components. Okay, what it is asking? It is asking you to draw a typical infiltration capacity curve. So you have to simply draw this curve. Okay, you have to simply draw this curve and indicate on it the various components. You have to indicate the various components as I have indicated over here. Okay, Fo, Ft, Fc, here T is equal to 0, T is equal to T, T is equal to capital T. Here infiltration capacity F is in centimeter per hour. Here time is in hours. Okay, so simply you have to draw this IC curve, infiltration capacity curve. Also, if infiltration capacity of a catchment is represented by F is equal to 0.5 plus 1.2 e to the power minus 0.5 t, determine the values of various components. Okay, we know this equation, Horton's equation. From this equation, we can determine the values of each component. Now see, the equation is given as F is equal to 0.5 plus 1.2 e to the power minus 0.5 t. So if we compare both the equations, what we find? We find that here it is Fc. Fc is equal to 0.5. Okay, so we found the component Fc. Fc is equal to 0.5. But this 0.5 has to be in what unit? It has to be in centimeter per hour. Now see, in problem it is not given whether it has to be in centimeter per hour or in millimeter per hour. If it is not given, then you can take it as centimeter per hour. If it is mentioned in millimeter per hour, then you will have to take this in millimeter per hour. Now since it is not mentioned in the problem, you have to take it as centimeter per hour. Because infiltration capacity value can be in centimeter per hour or millimeter per hour. Okay. So here you have to take it in centimeter per hour as it is not mentioned in the problem. Next, what is this? FO minus FC. FO minus FC will be equal to what? Will be equal to 1.2. This is equal to 1.2. We got FC as 0.5. So simply substituting the value of Fc equal to 0.5, what we will get? FO minus 0.5 is equal to 1.2. FO minus 0.5 is equal to 1.2. So what will be the value of FO? FO will be 1.2 plus 0.5. That comes out to 1.7 centimeter per hour. So FO value comes out to 1.7 centimeter per hour. And also here there is this term K, that is the decay coefficient. So K will be equal to what? See here K is equal to how much? 0.5. So K will be equal to 0.5. Now this K is in time inverse and here time is in R. So this will be equal to R inverse. Okay. So K is equal to 0.5 R inverse. So this is how you will be solving such problems if how to draw a typical infiltration capacity curve and how to find the various components of the infiltration capacity curve.